Welcome to the second in our series of flow chemistry webinars. Today we're going to be talking about some of the key benefits of flow chemistry and why you might want to perform your chemistry in continuous flow. If you attended the first session, we spoke about what flow chemistry is and discussed the principles behind flow chemistry. We're going to go into a little bit more detail with the time that we have and talk about some of the key benefits. So I guess what we're here for is to talk about why you would use a new synthetic technique over one that you're familiar with. So there are some key benefits that I'm going to highlight here, and we'll go through those in more detail as we progress this up and today. So we can potentially increase reaction rates. We can run faster reactions if our reactions are thermodynamically controlled. We can potentially run safer reactions. We can reduce the associated hazards with certain chemistry. We can perform reaction optimization in a faster and more efficient process by means of automation. This is a big statement, we can possibly achieve reactions or reaction conditions that aren't possible under traditional methods. So we can create things like reactive intermediates in situ and reactamol. We can create hazardous reagents and use them continuously. We can use the benefits or the technology of flow chemistry to make library arrays of compounds, and we can easily explore the diverse chemical space, harnessing the benefits. Our reactions are generally more selective. If we can increase the control of our reaction parameters, then generally we can be more selective in our reaction pathways. Scale up is easier in flow rather than batch. We can scale up from milligrams to kilograms with very little effort and resynthesis. Not only can we create and perform our reaction continuously, but we can also apply technology to do inline workup as well. So we can work up our reaction continuously. And we can integrate things like reaction analysis to continuously monitor the progression of our reaction, to get real-time feedback of our reaction progression. So let's think about some of the benefits. So the first one here would be selectivity. So let's think about running our reactions in batch. So step back a second. Poor selectivity generally comes from loss of reaction control or some variation in our reaction conditions. And we're thinking about parameters such as temperature, mixing, addition, molar ratios, concentration, time, things that we mentioned before. So if we think about the first one, temperature, when we're running our reaction in a